Okay, so now we're going to talk about finite differences. So when all of the x values in the data are equally spaced, so like the x values go by like ones or twos or fives or something the same amount. And if the differences, so like subtracting of the y values are the same or have a pattern, then it's a finite difference. So that we've already learned something about this. We've done this in the past. And so if we do the first differences and they're all equal, then it has a degree of 1, which means it is linear. If the second differences are equal, then it has a degree of 2, which means it's quadratic. We did that. And so let's extend that concept. So if the third differences are equal, then it has a degree of 3, so it's cubic. And if the fourth differences are equal, then it has a degree of 4, which is called a quartic function. And it would continue on. So we've done differences before. Let's do a refresher so you remember what we're talking about. So, okay, the x values are evenly spaced. Notice they're going by ones. We don't care what they're going by, they just have to be going by the same thing. So remember how we did this. This was back a chapter ago. We did 4 minus 1, and we get 3. And you don't need to show your work. I'm just going to do it on the first couple so that if it was you going back to your notes, you'd be like, oh, that's how I got that number. So then you do 10 minus 4, you get 6. You always do the right number minus the number just before it. So 20 minus 10 is 10, and so on. 35 minus 20 is 15. 56 minus 35 is 21. 84 minus 56 is 28. Okay, that's first differences right there. They are not all the same, and so therefore it is not linear. So what you have to do is you have to then do the second differences. So once again, I'm going to show my work here just so that you know what we did, and you can like kind of recreate it if you were stuck later on. So 6 minus 3 is 3. 10 minus 6 is 4. And then 15 minus 10 is 5. 21 minus 15 is 6. 28 minus 21 is 7. Okay, that's the second differences right there. They are not all the same. And so you are not doing a quadratic here. So now try the third differences. So just do it for a third row. So once again, you do the right number minus the one just before it. 4 minus 3 is 1. 5 minus 4 is 1. 6 minus 5 is 1. 7 minus 6 is 1. Okay, that's the third differences. And the third differences are all the same. So what that tells me is that it has a degree of 3. And so therefore it is a cubic. Now, it wants us to use technology to find the polynomial function. So go ahead and pause the video and grab your graphing calculator if you don't already have it out. Okay, so I got my graphing calculator out, and here's what I'm going to do. Scoot it over so we can see. The first thing I'm going to do is I'm going to go to my list and enter in my data. So I hit Stat, and I hit Enter on Edit. If you have data in here, remember you can go up and to where the black cursor is on L2, and you can hit Clear Enter. And then you can go up to where the black cursor is on L1, and you can hit Clear Enter. It'll just clear out your list. So go ahead and type in your x values into list 1 and your y values into list 2. Okay, and so where we go from here is we press Stat, we go over to Calc. Now, if it is a degree of 1, then use linear regression. If it's a degree of 2, it's a quadratic, use quadratic regression, number 5. If it's a degree of 3, we use cubic regression, number 6. If it's a degree of 4, use quartic regression, number 7. So ours is a degree of 3, so we need cubic regression. So you can go down to 6 and hit enter, or just press 6. The x's are in list 1. The y's are in list 2. And then go ahead and go down to calculate and hit enter. And here's your line. Notice it gives you the format. The A value is 0.16 repeating, right? And the B value is 0.5 and the C value is 0.3 repeating. So I'm just going to jot those down real quick. So A was 0.16 repeating, just the 6 is repeating. Okay, B was 0.5 and C was 0.3 repeating. Okay, and then also if you noticed, mine shows the R squared value is 1. That means it fits perfectly. So one thing I can do is I can go ahead and I can put in 0.1666666 repeating and do it out quite a ways. And then what I'm going to do is I'm going to go ahead and hit, let's see here, alpha y equals, and this fourth one is fraction to decimal or decimal to fraction, and I'm going to hit enter, and it tells me it is 1/6. So that's helpful to know. So it's y equals A was 1/6 x cubed, B was 0.5 or 1/2 x squared, C was 0.3 repeating, and so if you do 0.3 repeating, that's 1/3, and that was 1/3 x. And if we go back in and I show you this, and I go up here, I can go back to where I had done cubic regression to see what it was. And so notice the D is 0. That's why there's not a constant right there. I follow this format. Okay, let's try another one just to make sure we've got this. So you verified your x values are all going up or down by the same amount, so they're evenly spaced. So now what you're going to do is first difference, second, third, fourth differences, however many you need to show what the pattern is. So remember, you do 15 minus 6, 9. 22 minus 15 is 7. 21 minus 22 is -1. 6 minus 21 is -15. -29 minus 6 is -35. You can feel free to use a calculator if there's any of these you're just not ready to do in your head. First differences was not the same, so we're going to move on and we're going to try second differences. So second differences, 7 minus 9 is -2. Always do the right one minus the one right before it. -1 minus 7 is -8. -15 minus -1, that's like doing +1, it's -14. -35 minus -15 is like +15, and that's -20. So that was second differences, and so they're not the same, and so that means it's not a quadratic, and you move on to third differences. So -8 minus -2 is 6, whoops, it's -6. -14 minus -8 is -6. -20 minus -14 is -6. So third differences, once again, happen to be the same. They're not always third differences. Anything, I'd say we could do anything from first, second, third, or fourth. It goes on farther. The same concept continues, but I don't think the book will go higher than fourth. So this has a degree of 3, which tells me that it's cubic. And then so remember what I do from there is I go back to my calculator, move it over here so we can see. Anytime you want to get out of a screen, do second quit. Okay, I'm going to go to stat, and I'm going to hit enter on edit. To clear, I'm going to go up to L2 and hit clear enter. To clear L1, I'm going to go up to L1 and hit clear enter. And I'm going to type in my list. So my X values are, oops, doesn't like it when I use my keyboard. Okay, my X values are going to be -3, and then -2, zero, 1, 2. And do your Y value, so you have 6, 15, and 22, 21, 6, and -29. The bad thing about this is if you put something in wrong, it messes up your whole problem, so just be careful. Okay, so now what I'm going to do is I'm going to stat. I go over to calc, and because it was cubic, I'm choosing cubic regression, the 6th one. Go down to 6 and hit enter, or just hit the number 6. And so you see it gives us your format. So A is -1, B is -7, C is -7, and D is 21. And here's your format of exactly what variables everything goes in front of. That R squared being 1 just tells me it's perfect fit. Okay, so let's see if we can write it. So it was Y equals, A was -1, and it's in front of x cubed. So I'm going to put -x cubed. B was -7, and it was in front of x squared. C was -7, it was in front of x. And D was 21, which is the constant in this case. And there's my equation.